Welcome to another session of cellular mobile communications. Yeah, till now we discussed only the concept of global system for mobile and what is meant by global system for mobile, what are the techniques which are included in GSM, and what are the architecture of GSM, that is GSM contains a mobile station, base station subsystem, and operation subsystem and network and switching subsystem we discussed in previous sessions. Today we go for what are the other than GSM techniques which were used, that is miscellaneous mobile systems. Here in this section, we are briefly introduce the other systems like PDC, CT2, DECT, CDPD, PCN, and PCS, etc. The first one is TDD systems. You know the concept of TDD systems, that is time division duplex system, which is used in digital communications, that is digital systems, which is used for to transmit or receive the information using only single carrier for transmit and receiving with different time slots. Basically, there are two types of TDD systems, depends upon the multiple access techniques. That is TDD/FDMA, TDD/TDMA. That is in TDD/FDMA, nothing but each carrier serves only one user, that is fixed for particular users. But in TDD/TDMA, each carrier can have many time slots. Each time slot can be used by many users. Here, in this time division duplex system, a chunk of frequency spectrum is allocated to a particular user with separated two chunks of about 20 megahertz. 20 megahertz. Here, what is the use of separation of this 20 megahertz of two chunks of a spectrum? That is, this is used between the differentiate between transmitting and receiving information to avoid the interference. Yes, see this one, the difference between TDD/FDMA and TDD/TDMA. In TDD/TDMA, each carrier frequency allocate either transmit or receive, and it is fixed. That is, see this one, I am taking TR like this. That is transmission reception. That is, two frequencies are allocated to one user, one for transmitting, another for receiving. In TDD/TDMA, it is a slots, a frame. Each frame contains 8 time slots, right? First 8 time slots for transmission side, other 8 slots for reception. Likewise, go on. For this TDD/TDMA, there is no fixed one, right? Here, a card time we have to include for security purpose, and diversity scheme applied, and there is no interference problems in TDD/TDMA. Here, the main advantages of TDD, as follows. That is, when only one chunk of spectrum is available. Only one chunk of spectrum available for both transmission and reception purpose. Only for both transmission and reception of purpose. That is the best use of spectrum by using TDD. And diversity can be applied by using TDD system. That is what I mean diversity. That is, we are using two receivers at the end of the system. We receive the signals and combine them and go for checking whether it is equal or not. Right? That is the diversity scheme applied. That is space diversity scheme. Next system is Cordless phone 2. Cordless phone 2. That is CT2. That is, this is the second generation of the landline telephone. This is developed by GPT Limited in UK. This is also used TDD systems in CT2. Here, all the TDD systems such as PHS, DECT, whatever it may be, there is a basic is CT2. CT2 is nothing but it is advanced version of landline telephone. Here, what is the system structure of this cordless telephone 2? Here is carrier frequency is from 864.1 to 868.1 megahertz. The total spectrum is 4 megahertz. The channel access system is FDMA/TDD. Why it is FDMA now? Here we are using instead of TDMA. That is, this is a second generation. We are using this advanced for landline telephones. That's why we are using FDMA/TDD. And number of channels are 40. Channel width is 100 kilohertz spacing, and handset output power is 1 to 10 milliwatts. And what are the characteristics of CT2 is overall data rate is 72 kbps, and data rate per speech channel is 32 kbps, and speech coding is ADPCM, and modulation is GMSK. This is about cordless telephone 2. Here, the drawbacks of cordless cell phones with nothing but which maximum covers wireless connectivity by 10 meters. So that's why I had to go for the next one is cordless phone 3. Cordless phone 3, CT3. Actually, this is originally called as DCT 900. Originally, it is called as the DCT 900, and it is developed by Ericsson. It is an upgraded version of from CT2. Then, what is the system structure of this cordless phone 3 is number of times of which is equal to 64. Two-way call system is it is available. Diversity technique is available, and slow speed of handoff is available, and caller authentication is available. Encryption, roaming, so many features are available in cordless phone 3. And what are the characteristics of this CT3 is first one is handset effective radiated power, ERP. Handset effective radiated power is 80 milliwatts, and modulation is MSK, minimum shift keying. Spectrum range is 8 megahertz. The frequency range is 800 to 1000 megahertz. The bandwidth is 1 megahertz. RF output power is 80 milliwatts with peak, and number of slots per frame is 8. Overall data rate is 640 kbps. Data rate per speech code is 32 kbps, and speech coding is ADPCM. Almost it is the characteristic which is equal to CT2. The next system is Digital European Cordless Telecommunication System. Digital European Cordless Telecommunication System, DECT. This is the name it shows. It is European standard. It is just like CT2, and which is slightly differ from the general cellular systems. Here, where exactly used this DECT? Here, the first one is which is used in public network, which is used for that landline telephone to connect to mobile communication, and which is used from business communications locally. That is by using PBX, private branch exchanges. That is, we have to dial the extension number instead of all the numbers, and which provides mobile public access. That is PCS applications. That is which monitors the location of the handsets, and which is used in local loop. That is instead of total wireless connectivity, we have to running the copper wireless from your nearest telephone exchange to your home by the copper lines. In your home, we are connected to one wireless adapter. The system structure of DCT is duplex method is TDD, and access method is TDMA, and RF power of handset is 10 milliwatts. The channel width is 1.7 to 8 megahertz per channel. Number of carriers is 5. Frequency is between 1800 to 1900 megahertz. 1800 to 1900 megahertz. Another characteristics of this DECT is frame duration is 10 milliseconds, and with the number of time slots is 12. This is about system structure and characteristics of DECT. Next, we are go for what are the other full duplex systems. You know what is meant a full duplex system? At a time, both conversations from two terminals. That is the examples for this other full duplex system is first one is PDC, personal digital cellular. The second one is PCN, personal communication network. The third one is PCS, personal communication service. Now we discuss each and every one one by one. That is PDC, PCN, and PCS. The first one is PDC, personal digital cellular. Here, originally this personal digital cellular is implemented in the country of Japan. Actually, this is the type of multiple access technique which is used in PDC is TDMA, time division multiple access systems, with the operating frequency of 800 megahertz to 1.5 gigahertz. Actually, initially they are called, instead of PDC, they are called JDC, Japanese Digital System. Nowadays, we are using the name, it should be replaced by personal digital cellular. And here, this is used from the year of 1994. Here, we are using 9 interferences. Like in previous sessions, we have discussed about the interferences which is used in GSMEs, that is radio interface, A interface, ABS interface, like this. Here also, in personal digital cellular also, we are using 9 interfaces. 9 interfaces. First one is UM. UM is the air interface, that is radio interface between base station to mobile station. And like other interface like B, C, D, E, J, K, right? A, K, H, and A is the interference like this. Totally 9 interfaces are which is used in the structure of PDC. See this figure. What are the basic block diagrams which are used in PDC? That is MS mobile station, BS base station, MSC mobile switching center, and GLR gate location register, and HLR is home location register like this. Right, the connectivity between two MSC is by the GLR. That is, you know, the meaning of VLR, that is visitor location register in GSM. Like similarly in PDC also, instead of VLR, it is GLR, that is visitor location register, which is connecting between two MSCs. Right. Now we discuss what is UM. UM is the user interface, that is A is the interface between mobile station to base station, and base station to MSC is called A interface. From MSC to GLR is B interface, and MSC to HLR is C, and MSC to MSC directly connecting E interface, and GLR to MSC is K interface, and GLR to HLR is D interface. Likewise, totally 9 interfaces are available. What is the signaling structure which is used in PDC? Actually, the signaling structure it is based upon from ISO-OS layer model. Now, in this signaling structure of PDC, having only 3 layers. 3 layers. That is, first we have discussed about layer 3 concept. That is top layer. The layer 3 consists of 3 functionalities. 3 functional. That is call control. That is how to set up a call. And mobility management, nothing where the mobile is moving from one location to another location, how to change the frequency. And the radio transmission management. Radio transmission management. These are the basic 3 functionalities which we are used in the 3rd layer of the PDC. And layer 2, which is equal to addressing and retransmission control. Addressing, nothing but what is the address of source and what is the address of destination. And layer 1 is collision control and forward error correction, that is by the CRC method, cyclic redundancy check, and segmentation and reassembly. That is segmentation, reassembly, nothing but we have to use segmentation at transmission side and reassembling at receiving side. These are 3 layer concept of PDC. Here the system structure of this PDC is multiple access method is TDMA, and a number of time slots is 3. The characteristics are it starts from 800 MHz ends to 1500 MHz, and modulation is pi/4 DQPSK, and speech coder is VSLE ALP. This is the system structure and characteristics of PDC. The next one is next full duplex system is personal communication network, PCN. Originally, this is implemented by the scientist by Lord Young in the year of 1988. And some of the characteristics of this PCN are: first one is operational frequency is 1.7 to 1.88 gigahertz. Operational frequency 1.7 to 1.88 gigahertz. And use 30 gigahertz or more than 30 gigahertz for microwave backbone system, which covers both small and large cells, and which covers both inside and outside the buildings. And handoff takes place is available. Technique is available. Call delivery and portable handset, the small size of mobile unit, and uses intelligent network. Next one is the 3rd full duplex system is PCS, personal communication service. Originally, this personal communication service implemented in the year of 1991 by using FCC. Here we are using the spectrum between 1.85 to 2.2 gigahertz. This is exactly why what PCS works in both wideband and narrowband. Here in wideband is like cellular systems. Here divided into 2 parts. One is licensed part, unlicensed part of voice, unlicensed part of data, UV and UD. It divided a number of bands A, D, B, E, F, C, like this. Number of bands is there. The same A, D, B, E, F again we are using same with respect to UD and UV. One A is for receiving, one BA for transmission. That is, two frequencies are required, one for transmission, another for receiving. In narrowband, by using narrowband, we require more number of channels. The same thing can divide into number of channels. Next one is non-cellular systems. Non-cellular systems. Here, what not even non-cellular system thing, but we are cover the total system instead of cells. The first one is under this non-cellular system is cellular digital packet data, that is CDPD system. Mobile satellite communications. Mobile satellite communication, that is CDPD system. Mobile satellite communications. The first one is CDPD, cellular digital packet data system. Here in this CDPD, which is especially used for data transmission only, whenever the voice channels are ideal condition, voice channels are ideal condition, then automatically by using that voice channels, we have to send data. Here, what is the CDPD network reference model? See this one, SU, subscriber unit. Instead of mobile unit, we are using called as a SU, subscriber unit. SIM, subscriber identity module, and MDBS, right? Mobile data base station. MDG, mobile data gate. DSM, data service management. NIM, network identity module. MDG, DHLR. That is the same concept of GSM, but we have to that is represented by data now here. Here the interfaces are P, Q, UM, A, E, J, C, F, B, H, K, D, L, G. That is number of interfaces are available. But UM is the basic interface, that is, AIR is the interface between mobile unit to base station. That is SIM, nothing subscriber identity module, SU, subscriber unit, EIR, equipment identity register, MDPS, mobile data base station, MDZ, mobile data gateway, NIM, network interface manager, DHLR, data home location register, NAX, network address translator, DSM, data service manager, like NG network gateway. Here, what is the operation of this CDPD? Here, the first one you have to take the concept from MDBS, that is mobile data base station. This is just like cellular system, and DSM is the center for CDPD. This is just like MSC. This DSM is operated independently from MTSO, not for collaborate with MTSO or MSC. It is independent from DSM. Here, the two steps required for the operation of CDPD. First one is for a dedicated channel setup. Once your mobile unit is initialized, it scans for N CDPD channels. Which one is better CDP channel? We have to lock one strongest CDP channel. Once we have to receive strong CDPD channel, then automatically go for frequency hopping channel setup. This is done by sniffer. What is by sniffer? Sniffer is monitors what are the control channels and voice channels, whether it is ideal or if it is ideal, automatically transmit the data. Okay, what is the transmission structure of this CDPD? That is, it is roaming supports and security authenticated across the air link, and for ready technical connection, we are using Reed Solomon codes, and frequency aligned with in-band controlling, and cell transfer is controlled, power control is there, and AAP is compatible, and modulation is GMSK, and data rate is 19.2 kbps. Link control is LAPD, and it is useful for point-to-point, point-to-many, that is broadcasting or multicasting, whatever it may be. So it supports all types of networks. The next one is mobile satellite communication. Here in future, the mobile satellite communications will used instead of, especially for rural areas. Here, for this purpose, we are using 3 satellite altitude positions. One is for stationary satellites, which are above from 22,000 miles above from the Earth. The second satellite is low Earth orbit (LEO), which are used from 400 to 800 miles above the Earth, and medium Earth orbit satellites (MEOs) anywhere in between stationary satellites and LEO satellites. That is, instead of using base stations, directly connect between mobile to mobile through satellites. You know the stationary satellites. Here the stationary satellite is above from the 22,000 miles above from the Earth. For this purpose, we are using 4 satellites are required to cover the total Earth. And for each satellite work with the lifetime of 10 to 15 years. 10 to 15 years. The maximum delay occurs is 0.25 seconds in 2 ways. This is about miscellaneous cellular systems like cordless telephone 2, cordless telephone 3, DECT, and full duplex systems like PDC, PCS, PCN, like satellites, and CDPD. Right. These are some miscellaneous cellular systems. Thank you for watching today's session. Do you have any query? Type your query in the chat box related to miscellaneous cellular systems.